Mobile radio access networks are seeing a paradigm shift from proprietary interfaces to open interfaces. The radio base station and the radio are typically connected through a proprietary interface called CPRI. With the advent of Open RAN, this interface becomes open, standardized, and can run over Ethernet. This really allows mobile network operators to mix and match equipment from different vendors in their network. With more openness, there's also new challenges for both the system integrator and the operator. The first challenge is efficient O-RAN compliance testing to really ensure that a base station and a radio from different vendors interoperate correctly in a network. The second challenge is coexistence. While CPRI-based equipment is still running in a network and O-RAN compliant equipment is being rolled out, operators really need a cost-effective way to multiplex both solutions over a single fronthaul link. In this video, we at Xilinx have partnered with Keysight and Cisco to show you how these two challenges can be met to make open networks a reality.
The O-RAN fronthaul interface consists of 4 separate logical links or planes. A control and a user plane, which contain the actual radio signal, a synchronization plane, which keeps the RU and DU in sync, and a management plane which controls and monitors the RU. We call these planes the C, U, S and M plane. Now let's take a look at the setup we've put together. First, we have the Keysight S5040A O-RAN tester. It's basically an ODU emulator with parametric control of the O-RAN interface. It emulates various features of the O-RAN standard and can mimic different O-RAN IoT profiles.
On the S-plane, the O-RAN tester acts as a PTP grandmaster, providing synchronization to other equipment. In addition, it also provides triggers to measurement equipment to ensure that the device under test and the test environment are on the same clock and time reference. On the CU plane, the O-RAN tester runs Keysight's U5040B Open RAN Studio software. The software generates and transmits O-RAN packet streams to an RU and can capture and decode uplink packets sent back from the RU. Finally, the O-RAN tester comes with an M-plane client. Using a command line interface and XML files, you can define tests for managing and configuring the RU. You also have the choice to either merge the M-plane traffic with the CUS plane traffic via a feed-through mechanism, or to use a completely separate interface for M-plane traffic.
To showcase the handling of legacy equipment, we have deployed a CPRI tester, which serves as a baseband unit for a legacy remote radio head. Next, we have our fronthaul network. It consists of 2 Cisco NCS540FH fronthaul gateways.
Cisco NCS540FH series routers are designed to meet and exceed stringent bandwidth, latency, and scalability performance demands of 5G packet transport. This fully programmable platform allows customers to converge CPRI, eCPRI, fronthaul gateway, and Ethernet services to simplify the mobile network architecture end-to-end and significantly reduces operator TCO. NCS540 routers serve as ingress and egress points to what could be a larger fronthaul network. 2 fiber pairs are used to showcase this here, but it could be any combination of links or additional routers. In this application, the Keysight Open RAN Studio feeds 10 gigabit per second Ethernet traffic to the fronthaul gateway, which is then passed on a 25 gigabit per second Ethernet link to the second router, where it's converted back to 10 gigabit per second Ethernet and forwarded to an RU. This process is relatively simple as O-RAN is using Ethernet packets natively. At the same time, however, we can feed CPRI traffic to the routers where it's packetized to Ethernet. This is done based on the IEEE 1914.3 radio over Ethernet standard. At the egress router, it'll be converted back to CPRI to feed a remote radio head. This conversion of CPRI to Ethernet is very important because it allows operators to build an Ethernet-only fronthaul network without having to worry about support for their legacy CPRI equipment.
And of course, this Cisco solution is deployed using Xilinx silicon inside. Next, we have our RU, which in this case is a Xilinx reference design for a massive MIMO radio unit we call the Array 4032. It features 32 transceiver chains and runs the O-RAN, COS and M-plane powered by 3 Xilinx RF SoC chips. As we're not in an anechoic chamber where we can radiate the RF signal, we have removed the radome and are using a cabled connection.
And finally, we have a legacy CPRI remote radio head together with its power amplifier.
To measure RF signals in the downlink and to feed signals in the uplink, we have deployed a Keysight spectrum analyzer and a Keysight signal generator.
So to summarize, in this setup you can see the latest Keysight O-RAN testing solution acting as a DU and RF source analyzer feeding a Xilinx massive MIMO O-RU. They're interconnected by Cisco fronthaul gateways, which can simultaneously transport legacy CPRI. 3 different companies, all interoperating smoothly based on the O-RAN fronthaul standard. Now let's look on how to test an RU using Keysight's solution. For that, we'll run a simple LTE TDD uplink test, which will nicely illustrate all the interaction among the equipment. A signal source will be used to feed the uplink signal into the RU. In O-RAN, an RU does not automatically know which TDD symbol is uplink and which is downlink. Instead, the DU will send a C-plane message to instruct the RU on that. So a test solution will have to do 3 things: generate a signal for the signal source, generate the proper O-RAN C-plane messages and send them to the RU, and finally capture and analyze the U-plane messages received in return. For this, we first set up a simple uplink signal in Keysight Signal Studio by selecting a pre-configured reference channel in the software. We then generate a waveform file and load the file onto the RF signal source. Next, we import the same Signal Studio project file into Keysight's Open RAN Studio. From this file, Open RAN Studio generates the matching C-plane packets. The Open RAN Studio also includes a packet explorer so you can review the generated packets. As you can see, only a few small C-plane packets were generated, telling the RU for which subframe to send uplink packets. As mentioned before, Open RAN Studio provides also a trigger to the signal source to start playback of the waveform, while it syncs with the RU using O-RAN's S-plane. Now we're ready to execute the test. The Keysight Open RAN Studio player sends C-plane packets through the FH network to the Xilinx RU. At the same time, it triggers the signal source to send the uplink RF signal. The RU receives the signal and sends back U-plane packets to the DU emulator. As you can see in the traffic monitor, there's only very little C-plane traffic going from DU to RU, and considerably more U-plane traffic from RU to DU. Now we just need to analyze what's been sent back. For that, we capture O-RAN packets in Keysight Open RAN Studio and extract the payload as an IQ data file. We can then use Keysight 89600 VSA software to play back the received IQ data. As you can see, the VSA software can properly decode and demodulate the uplink signal extracted from the O-RAN packets and reports an EVM of 0.8%. As a next showcase, let's take a closer look at the Cisco fronthaul gateway. First, note that while we were running our O-RAN uplink test, CPRI was running continuously in the background. The CPRI ROE traffic and O-RAN traffic are carried within defined classes of service over separate transport slices. If we look at the downlink signal from our CPRI remote radio head, we can see that it also shows a good EVM, indicating that CPRI traffic runs smoothly and parallel to the O-RAN traffic. Remember that CPRI is a completely different transport method, which relies on continuous streams instead of packets like Ethernet. So the ingress and egress routers have to convert a stream to packets and vice versa, ensuring low delay, proper synchronization, multiplexing with the O-RAN packets, and so on, while making it appear to the CPRI devices as if they were connected directly with no packet network in between. At the same time, the Cisco NCS540 can provide redundancy to radio services in case of link outage. Both routers are connected by 2 pairs of fiber, but only one is actually used. If we disconnect the link in use, the services will automatically switch to a new route within 50 milliseconds, ensuring almost no interruption in service. Finally, the NCS540 has its own management interface. It implements several Yang data models, including ones from IETF and OpenConfig, as well as Cisco-specific ones for CPRI and ROE. Using a netconf client and a visualization tool, we can read the data models to check hardware-specific parameters such as temperature and link status, configurations like the ROE mapper type, or packet counters to monitor our network. Through this demonstration, we highlighted that the convergence of legacy CPRI and modern O-RAN fronthaul is possible using Ethernet-based equipment. We also showed test methodologies used to validate both the O-RAN devices and the transport network.
We hope you enjoyed this demonstration of key O-RAN technologies. The Xilinx Massive MIMO Radio Reference Design, Keysight O-RAN Testing Solutions and Cisco Fronthaul Gateway are all validated according to O-RAN standards. Keysight and Cisco O-RAN products are commercially available. For more information, visit our company websites.